introduced you wrong, so please.
Good morning, everyone. My name is Dang Linying. I came from China Aerodynamics Research and Development Center. I am the co-author of the paper. The title of the paper is GPU Parallel Algorithm for Hypersonic Flow Around Asteroid. I will give the presentation from 5 parts. The first part is GPU, new technology for numerical simulation. The development of SAP depends on available computational capacity. Nowadays we saw more structural details and more complex physical and chemical process. And we want to meet higher requirements such as reliability, multi-objective, and real-time. Graphics processing unit with thousands of streaming processors SP. GPU has amazing float point performance, which makes it suitable for computational intensive applications such as computational fluid dynamics, CFD. Characteristics of GPU. The GPU is suitable for single instruction multi-data SIMD algorithm without data dependency. We can run multiple threads at the same time, one thread per SIMT. The first part is a model of hypersonic flow around asteroid. The governing equation of the gas dynamics we use is chemical non-equilibrium, Navier-Stokes equations, and with conjunction with Duncan's chemical model. We solve the equations with finite volume method, and we use an implicit method. We know the velocity of asteroid into the atmosphere of the Earth is very high, and typical value is 20 kilometers per second. Thus, we calculate some dynamic properties of gas species at high temperatures from 250,000 Kelvin. We use the fragmented curve fitting method in the reference. The left picture is heat capacity at constant pressure. The right picture is the enthalpy of the gas species. The third part is CUDA implementation of SAFD. Implicit method without dependency. For the GPU use, explicit scheme is a good choice, but when CFL restrict the time step of the implicit method is too small. Thus, we use an implicit method called data parallel lower and upper relaxation method. In this method, the input and output variables of the internal relaxation step are different. So there's no data dependency. There are 3 levels of parallel. One is among the cells. The other is among mesh blocks. And the third is among computational nodes. Among cells, there is a thread level parallelism based on CUDA. Among the mesh blocks, there is a task level parallelism based on stream. And among the computational nodes, there is processing level parallelism based on MPI. There are 4 types of variables in the program. Global variables, constant parameters, input array, and temporary variables. So we should treat the 4 types of variables separately on its merit for the data storage. CUDA kernel design. The CUDA kernel design is the code of CUDA thread. We use SIMT, single instructor, multiple thread, to set thread action and its objects. The fourth part, discussion of the results. The computing device in my paper is include 2 types. The CPU is Intel Gold 6126. The GPU is NVIDIA Tesla P100. These are property parameters. Case 1, chemical non-equilibrium flow around Apollo spacecraft in flow conditions. The velocity of free stream is about 8 kilometers per second, and we use 1 million mesh, and we use 5 species air model. These figures displayed here are Mach number contour, pressure contour, and the temperature contour. We compare the aerodynamics coefficients calculated by GPU with the results in the reference. They agree well. The computational efficiency. For the single GPU, the time consumed is about 12.5 minutes. For 2 GPUs, the time consumed is 7.3 minutes. And for 4 GPUs, the time consumed is about 4 minutes. And we see the speed up ratio is high. For the single GPU, the speed up ratio is 134.8. The case 2 is the flow around an asteroid. We assume its shape is a sphere and has a radius 1 meter. In flow conditions, the flow condition, the velocity of the flow stream is 20 kilometers per second, and the flow condition is correspond to an altitude of 60 kilometers. We use the 11 species A model. These figures are pressure contour, temperature contour, the pressure distribution along stagnation line, and the temperature distribution along stagnation line. We see the temperature is high. This, it seems a little inaccurate because now we have not included the radiation and ablation in the model. Computational efficiency. For the single GPUs, the time consumed is 44 minutes. For 2 GPUs, time consumed is 29 minutes. For 4 GPUs, the time consumed is 20 minutes. Conclusions. In this paper, we use DPR-UR implicit method to ensure data-dependent parallelism of safety. We use hierarchical parallel model to design GPU algorithm for safety. We obtain hypersonic flow field around asteroid for an 1 meter radius with velocity of 20 kilometers per second. The algorithm has high reliability. The speed up ratio reached 164.8 with single GPU device. The research is preliminary and has some shortcomings. The radiation of the shock layer and ablation of materials should be included because of the higher entry velocity larger than 2 second common velocity. Then that's all. Thank you.
Thank
for
you.
question.
We have time for one comment or question, if anyone has it. Okay.